Hi there, folks. This is the Unit 4 test, and as always, I am the amazing Mr. Jansen. So here we go. If we look at this, these first two, we're just identifying each of these pieces of the function. And the first thing we're looking at is increasing versus decreasing. Remember, the function is increasing when it basically has a positive slope as we go from left to right if the function is going up. So when we look at this one, it's decreasing. It's going down from here until it gets to here. And then it's increasing, it's going up, got a positive slope, and then it decreases, and then once again it increases, okay? And we want to list the x values for this, and basically in between here, it's not really doing much of anything. These are turning points, so it's not increasing or decreasing at those values. So then when I look where it's increasing, the stuff that's in green, it increases from here to here, which is from -3 to 0. And then it also increases from here to forever, so from 3 to infinity. And then in terms of decreasing, it's decreasing where I have it in red, so it decreases from here until the -3, so from -infinity to -3. And then it also decreases from the 0 to the +3, so from here to here. Okay? Increasing and decreasing. In terms of relative maximum and minimum, these are going to stem from our turning points. The relative maximum is a relative high point, which is right here at 0, 0. And then there's two relative minimums. Remember, relative minimums are just low points where it goes from decreasing to increasing. So I have two relative minimums, one of them at -3, -4, and the other one at 3, -6. Okay. In terms of the end behavior, I'm just looking at the ends of the graph. I look as x goes to -infinity, and then I look at as x goes to +infinity. When I look at -infinity on my graph for the x values, I'm just looking at this side of the graph. Okay? And it's going up, which means my f of x is going to +infinity. When I look at as x goes to +infinity, I'm looking at the right side of the graph, and this time it's going up as well, so f of x is also going to +infinity for that one. Okay. The next one's very similar, increasing and decreasing. Here it's the same thing with green and red. It's increasing, and then it's decreasing. And then after that, it turns one more time, and it increases to forever. So basically, I write out the x values. It's increasing from -infinity until -2. And then it's also increasing from +1 to infinity. And then in terms of decreasing, it's decreasing from -2 to +1. And we use parentheses for all those because none of those values are included. Relative maximum is right here. Looks like the ordered pair -2, 3. And then there's a relative minimum right here. Looks like the ordered pair 1, -3. And then end behavior is essentially the same thing. We're looking as x goes to -infinity, and then we're seeing what the function does as x goes to +infinity. So x going to -infinity is this side of the graph, which goes down. So f of x is going to -infinity. And then looking as x goes to +infinity is the right side of the graph, which is going up. So that's f of x going to +infinity. Okay? For these, if we want to state the end behavior for each of these, I'm just plugging these in algebraically. I'm still looking as x goes to negative or positive infinity. And for this one, when it's in standard form, we essentially ignore everything except the term that has the highest exponent. And then I just plug this in. And really, this is just me playing a game with the signs here. So when I plug a negative in, if I do a negative to the 6th power is a positive, so that would give me a positive infinity, times a -2 is a negative infinity. So when I plug a negative infinity in, I get a negative infinity out. And then I do the same thing with the positive infinity. If I plug a positive infinity in here, positive infinity to the 6th power is infinity, times the -2 is also a negative infinity. So that goes to negative infinity as well. And that's it. We're just plugging it in. Okay? For this one, I do the same thing, except I have to plug it into each. Since it's not in standard form, I'm just going to plug it in for x and see what I get out for y. And really, my focus is whether or not it's positive or negative. So when I plug a negative infinity in here, Negative infinity squared is a positive infinity, and then I tack on this negative sign. When I plug a negative infinity here, I get negative, and then a negative infinity. So now I just have a negative times a negative times a negative, which is a negative infinity. So when I plug a negative in, I get a negative out. And then I do the same thing with positive. I plug the positive value in. So I have positive infinity squared, which is infinity, and then tack on this negative sign. This is a positive infinity. This is a positive infinity. So now I have negative times positive, which is also a negative infinity. And that's it. Okay? So algebraically, we're just plugging in positive and negative infinity, seeing what we get out for y. For this one, we want to sketch a possible graph. And this doesn't have to be done with great accuracy. We just want to get a general shape here. So I list my x-intercepts. So I set each of these equal to 0 and solve each. Finding the x-intercepts. Here I multiply each side by the -2. I find out that x equals 0. Here I add the 4, x equals 4. Here I subtract the 3, x equals a -3. So these are my x-intercepts at -3, 0, and a +4. And now from here, I just need to decide what's happening with this. So I'm going to look at the multiplicity of each of these. When you look at multiplicity, you're looking at how many times I get each of these solutions. I got this solution once, this solution once, and this solution once. And what that tells me in terms of multiplicity, if the multiplicity is odd, I'm going to pass through the x-axis. And if the multiplicity is even, I'm just going to touch the x-axis. So for this one, I'm going to pass through each time. So really, I just need to decide if my function is going to look like this, or if my function is going to look like this. And really, the thing that determines that is going to be the end behavior. So what I'm going to do is I'm going to determine the end behavior. I'm going to find the end behavior of this by plugging in positive or negative infinity. So x going to negative infinity. I plug a negative infinity in. That's going to be a right here, a negative times a -1/2. So I have negative times negative times negative times negative, which is positive. So again, it's just a game that I'm playing with the sign, so that's positive infinity. And then I plug the positive infinity in and see what I get out. And again, when I do that, I still have the -1/2 out front, but now it's positive times positive. So now that's going to give me a negative. And what that tells me, at the negative end, I should be going to positive infinity, which is up this way. At the positive end, I should be going to negative infinity, which is down this way, which means my graph has to look something like this. Okay? And in terms of gaining more accuracy, I can plug in points that are in between here. I could find that local maximum minimum. But really, what I want is a general sketch so I know where the local maximum minimum are located. If I look at the next one, I do the same thing. I set each factor equal to 0. So I have x equals 0. I have x plus 5 equals 0. And I have x minus 2 equals 0. And I solve each. This one's already solved. This one gives me a -5. And this one gives me a +2. And really, I go back to multiplicity again. In terms of multiplicity, the x equals 0 happened twice because there's 2 of them. There's an x squared. So that happened twice. This one only happened once. And then this one, there's 2 of this x minus 2, which means I would get this answer twice as well. And again, when I plot this, it's telling me whether I'm going to pass through or just touch the x-axis at those values. All right? And so what happens here is I know I'm going to pass through at -5 and I'm going to touch at the other values, which means either the graph goes like this, or the graph does something more like this. But either way, I'm touching at those 2 values and passing through at the other value. I need to determine end behavior one more time in order to figure out which of these it's going to be. So I look as x goes to negative infinity. When I plug that in, I just have to be very careful here. Negative infinity squared is a positive times a negative infinity. Again, negative infinity squared is a positive. So when I plug a negative infinity in, it looks like I get a negative infinity out. And when I plug a positive infinity in, a positive infinity squared is a positive times a positive, and then positive infinity squared is also positive. Positive and positive and positive gives me a positive infinity. And so really it determines that at this first end I'm going to be heading down this way. At the second end I'm going to be heading up this way. I know I have to pass through, touch, touch, and continue up. Okay, so it gives me a quick general sketch of what this thing should look like. For this one, I want to determine if this is a 0, and I'm going to test it using synthetic division. So I put my 0 in the box, and I write down my coefficients, the 3, the -7, the -4, and the +12. With synthetic division, I bring the first coefficient down. I multiply what's in the box times what's down here is a 6. I add straight down, gives me a -1. What's in the box times what's underneath gives me a -2. I add straight down. What's in the box times what's underneath gives me a -12, and I add straight down, and that's a 0. And to test this, really, I'm just looking at this remainder. That is the thing that I get when I plug the 2 in. So it gives me a 0, which means, yes, this is a 0 for my function. And I do the same thing with the next one. Now I'm testing a -3. And the function I have gives me a 1, a 0, because I'm missing the x cubed term. Remember, you have to plug zeros in for missing terms. Need everything in descending order. I bring down the 1. I multiply. I add straight down. I multiply. I add straight down. I multiply. I add straight down. And I multiply. And I add straight down. And I get a 24. Okay? So this time when I plug the -3 in, I get a 24 out. So the answer is no. This one is not a 0 for my function. And really, we're going to use that for an example like this. This time I'm giving you a 0, and -1 is a 0 of the function because it equals 0 when I plug it in, which means if I do -1 and divide this thing using synthetic division, what this tells me, obviously I was going to get a 0 here because I said this thing was a 0. But what it tells me, if -1 is a 0, it means x plus 1 is one of my factors. And then the other factor I get when I divide the x plus 1 out is right here. It's the x squared minus 16. So in other words, when I divide that out, I'm essentially factoring. This factors into an x plus 1 times an x squared minus 16. And now if I want to find the remaining zeros, I just completely factor this thing. X squared minus 16 is an x plus 4 and an x minus 4. And then you set each factor equal to 0. Here I find out that x equals -1. Here I find out that x equals a -4. Here I find out that x equals a +4. So those are my 3 solutions. That's it. In the next one, it's very similar. I'm giving you the fact that 4 is one of the zeros. I can divide that out and essentially use that to factor this thing. And it's not surprising that I get a 0 there. But x equaling a 4 means that x minus 4 is one of my factors. My other factor, once again, is written right here. That's an x squared plus 8x plus 15. And now I can finish factoring this thing. X squared plus 8x plus 15 factors into an x plus 3 and an x plus 5. And now I just set each factor equal to 0. Here I find out that x equals 4. Here I find that x equals a -3. And here I find that x equals a -5. And that's it. For the next one, I want to find all the zeros, and this time I'm not given a 0. So I'm essentially just going to do guess and check. All right, I take the values of the constant term, the -8. So factors of that constant term are like a 1, a 2, a 4, and an 8. And then I would also have the negative versions of each of those. And I would divide each of those factors by the factor of the a value, which is 1. So I'm going to leave these the way they are. And I'm just going to take a guess. So maybe I'll guess something like a 2 when I plug it in. 1, -1, -10, and -8. And I use my synthetic division. I multiply, I add straight down. I multiply, I add straight down. I multiply, and I add straight down. That gives me a -16. So I was close, but it's not quite it. It's not exactly what I was looking for. I needed to get a 0 here. So then maybe I'll try something like a -2 instead. So I bring down the 1. I multiply. I add straight down. I multiply. I add straight down. I multiply. Sorry, that's a negative. That's a positive. And I add straight down. And this one does give me a 0. So that means that's one of my solutions. So I tried the 2. That didn't work. And then I found that the -2 works, which means x plus 2 is one of my factors. The other factor is right down here. It's the x squared minus 3x minus 4. And now I can set each factor equal to 0. This thing factors into an x minus 4 and an x plus 1. And I solve each. X equals a -2, x equals a +4, and x equals a -1. And those are my 3 solutions.